Hey guys, welcome to the tail end of our measurement and geometry series from the Year 10 syllabus. Now, we are looking in the next two videos at a very special 3D shape, and this is the sphere. Now, the sphere to 3D shapes is kind of like what the circle is to 2D shapes. It's really weird. The edges make things very hard to just flat out calculate, and especially as you see when we talk about area and surface area, spheres behave in a very unique type of way. Now, I've drawn a sphere here. It's just a regular circle, but I've drawn these little lines here to give it a bit of depth. Hopefully it makes it look a bit more 3D. I'm not very good at art, so it's not going to look that great. But with our sphere, we want to look at the surface area. So with any sphere, you hopefully have seen spheres like this in everyday life. So think about any kind of ball, like a soccer ball, basketball, tennis ball. They all have this spherical shape where it's a 3D circle essentially, and no matter what way you turn it around, you're always going to get left with a circle here. Now, to work with this, particularly with surface area, it's very hard to kind of visualize how we can lay this thing flat out and even come up with a net for something like this. But I'm going to run you guys through something that I was shown, a little cool activity which you can do at home as well if you really care and want to see how this formula for the surface area of a sphere came about. And like with my usual videos, there's going to be a little bit of explaining of the concept. So if you don't really care and you just want to get into working with this particular formula, you can go ahead and do that. Now, let's go into thinking about this a little bit. Now, when I was at uni a couple of years ago, one of my lecturers gave me a really good strategy for showing people, kind of discovering for yourself why the surface area of a sphere is what it is. Now, I'm just going to give you the formula right off the bat, down the bottom here. So the surface area of a sphere is going to be 4 pi r squared. Now, what does this actually look like? Let's just break down what this formula is telling us. Well, pi r squared is just the area of one circle. So it's the area of a circle. And this 4 is getting multiplied by this in the formula. Because with algebra and any expressions like this, when we write numbers next to each other, so for example 4 in front of pi or in front of r squared, that implies a multiplication. So this is basically saying the surface area of a sphere is 4 different circles, the area of 4 circles with this same radius. Now, if you think of a sphere and you draw a radius out to some portion, and no matter which way you rotate this sphere, you will always get the same radius. So my surface area of a sphere is just 4 is equal to 4 times the area of the one circle. So 4 lots of the area of a circle. Now, as I mentioned before, when I was at uni, one of my lecturers, she gave us a really cool way to think about this. So if you want to do this at home, you will have to buy an orange. So you buy an orange from the shop, and what you're going to do is you are going to put this on a sheet of paper. So you can put your orange on the sheet of paper. You shade it in and, well, sorry, you don't shade it in. You place it on your paper and you draw a little border around it, like so. And you do this a few different times. So you move the orange around. You can do a 5th one if you'd like. And once you've done this, drawn around the outside, and you start to peel the orange, and you put it into all of these different circles, you will see that the outside, the peeling bit of the orange that you take off, fills out exactly 4 different circles of the same dimensions, because you're using the same orange to draw this around. Now, obviously an orange isn't always a perfect circle, but we get a pretty good approximation. And what that tells us is that to find the surface area of a sphere, we just find what the area is of that circle. So we take the radius we're given in the question, we find the area of that circle, and we just multiply it by 4. So we'll have a couple of goes at some different questions here. Let's jump straight in. Now, I know the explanation was a little bit of a cop-out, but if you do try this at home, you will see this done in a really nice way. It'll work really nicely. Maybe in the future I'll do a video where we actually show you this, where it's me recording myself doing this activity, but for now we have the formula. Now we can just use it here. Okay, so we want to find the surface area of a sphere with a radius of 7 centimeters. Okay, so to approach this, we're just going to write up our surface area formula. So the surface area of my sphere, and I'll add these little lines to try to make it look a bit more 3D. That is going to be 4 times the area of this circle, pi r squared. Now, I need to find the area of this circle, so I'm going to substitute my radius into here. So, my surface area becomes 4 times pi, times my radius of 7 centimeters squared. And if I pop that into my calculator, round it off to 2 decimal places, I will get that this is 615.75 centimeters squared. Okay, perfect. Now, let's do one more question here. So here, instead, I'm going to say that the surface area of this sphere, which has some unknown radius r meters, that has a volume, sorry, not a volume, we're looking at surface area. This has a surface area of, let's go 1,500 meters squared. So we want to actually find this time what the radius is. Now, I have my surface area here of 1,500 meters. So I'm just going to write that here, and that is going to equal to what I know about the formula for surface area, which is that surface area is 4 lots of pi r squared. So I have 1,500 equals 4 times pi r squared. Okay, so now we have an equation set up, something that we want to work through. Now remember, the thing we're isolating here is going to be my radius here. So I want to chip away at these other parts of my equation, these guys here, in order to get to my radius. So what I'm going to do first, I see 4 multiplying by pi r squared. So I can do the opposite operation. I'm going to divide both sides by 4 just to give me the area of my circle here. The area of one of these circles. So this guy here, for example. Okay, so dividing 1,500 by 4 gives me 375. 5 equals to pi r squared. Okay, now we've gotten one step closer. We want to isolate this r, so we can undo the multiplication of pi to this r squared, and we can do that by dividing both sides by pi. What this is going to do is it's going to give me r squared on its own, my radius squared, and I'm going to leave the left side in exact form, so I'm not going to do any rounding. I'm just going to write 375 divided by pi. So 375 divided by 3.14, etc. Okay, now I'm at my last step here. I have some radius all squared. So a number times a number gives me 375 over pi. And you may remember when we're working with squared numbers, to undo this squaring, we can take the square root of both sides. And taking the square root of both sides, on the right, it's going to undo my squared, which just gives me r. And on the left-hand side, I'm going to get 375 over pi. So when I put this into my calculator, 375 divided by pi and the square root of that, that is going to give me, for my radius, let's do it to 2 decimal places, 10.93 here. And remember, the radius here measures a length. So the surface area is going to be in meters squared, but this is just some kind of length, which is going to be in meters. So when we get to our final answer, we're going to do 10.93 meters, correct to 2 decimal places. But that brings us to the end of this video. We have been using, throughout these two questions, the surface area of a sphere formula. And it's kind of weird, but what it essentially communicates to us is that the surface area of a sphere gives me 4 lots of the area of a circle with these particular dimensions. Say the middle cross section of my sphere. If I was just looking way out at it, it's the radius from the center going to some outside point. So we have our formula here, and if you would like to, you can try the orange activity at home, but I'll probably do a video later on just getting us to thinking about how we can use this, how we can actually do this orange example and draw it out, and how you can conduct this experiment at home. But that brings us to the end of the video today. Thank you so much for watching, and I'll see you in the next one.